محمد وعلى آله وصحبه أجمعين. This is the second section in chapter 5, and it is about the binomial probability distribution. This is the most famous example of discrete probabilities distributions. So the first theoretical probability distribution we will consider is the binomial distribution. It describes process whose trials have only two possible outcomes. So we are dealing here with experiments with only two possible outcomes. Like, for example, tossing a coin, you have a head or tail. So tossing a coin is an example of the binomial probability distribution. Of course, there are other conditions that we are going to talk about. But let us give some examples about two possible outcomes. The physical events described by this type of process are widespread. For instance, this is the first example. A quality control system in a manufacturing plant labels each tested item. We test the items and we label each one of them either defective or acceptable. So defective or acceptable. We test each item, label it defective or acceptable, two outcomes. So this is an example of two possible outcomes. A firm bidding for a contract either will or will not get the contract. So the firm bid for the contract and the result would be the company or the firm will get the contract or will not get the contract. So there are two possible outcomes. A marketing research firm may receive responses to a questionnaire in the form of yes, I will buy, no, I will not buy. So there are only two answers, yes, I will buy, no, I will not buy. The personnel manager in an organization is faced with two possible outcomes each time he offers a job. So this is the manager, he offers a job, and the response would be always, I accept the offer, or I reject the offer. So these are some examples of some experiments with two possible outcomes. Now, what are the characteristics of the binomial distribution? The binomial distribution requires that the experiment's trials be independent. So this is the first condition. The trials should be independent. And independent means each trial does not affect the second one, the next trial. So for example, here, when the manager give the offer to a person, whether he will accept or reject does not affect the next person. Okay, the next person will give his opinion independently from the first one. So it has to be independent. The trials has to be independent. When you toss a coin, the second time is independent of the first time. If the first time is head, you don't know about the second time. Independence. There is no affection. They don't affect each other. So this is what we mean by independence. This can be assured if the sampling is performed with replacement. So usually, binomial distribution, we take with replacement from a finite population. So we choose with replacement from a finite population. So what is the meaning of replacement? When you take with replacement, this means the item is sampled from a population and returned to the population. So assume there are 30 students in the class, and I am going to select I select 5 students from the class. But I'll select 5 students with replacement. So what does it mean? I select the first student and I put it back in the class. Okay. So I select student number 1 and I put it back in the class. So I can select the same student again and again. Okay. This is with the replacements. And the number of students each trial will remain 30. Because each time you take an item, you put it back in the population. But this is what we mean by with replacement. After its characteristics have been recorded, I record what characteristic, I answer the question yes or no, and then I put it back into the population before the next time is sampled. However, sampling with replacement is the exception. In real life problems, usually you don't sample with replacement. Once you choose something, you keep it with you, rather than the rules in business applications. Okay, so in business applications, usually we don't use with replacement. So what would be the examples of binomial distributions then? Most often, the sampling is performed without replacement. We don't put it back. Strictly speaking, when sampling is performed without replacement, okay, if it is without replacement, could it be a binomial? The conditions for the binomial distribution cannot be satisfied. In general, okay, strictly speaking, cannot be satisfied. However, the conditions are approximately satisfied. Okay, if the sample selected, the sample you select from the population is quite small relative to the size of the population. So if the sample size is small relatively or relative to the population size, then the conditions of the binomial distribution could be met. Okay, but what do you mean by small? Well, a commonly used rule of thumb is that the binomial distribution, and now this is the important sentence, the binomial distribution can be applied if the sample size is at most mean less than or equal to 5% of the population size. 5%. So if the population size is 100, you take 5 or less. Okay, if you take 5 or less, this means, okay, the binomial distribution can be approximately applied. Okay, what are the conditions? So the main thing here, that remember that binomial distribution with replacement. If you take your experiment without replacement, make sure that the sample size is at most 5% of the population size. So these conditions would be met. A trial has only two possible outcomes, as we mentioned. We will call one of them success and the other one failure. Okay, so always one of them would be success and the other one would be failure. Who will determine the success and the failure? For example, when you toss a coin, which one is success, which one is failure, head or tail? Well, this will appear in the question. I will ask, when I ask, for example, toss a coin 10 times, what is the probability of obtaining 3 heads? 3 heads, so I'm asking about heads. So in this case, heads will be the success. So whatever you ask about or the question asks about would be the success, and the other one would be the failure. There is a fixed number of identical trials, n. So n is the number of trials, and this number is usually the number has to be given in the question. Okay, he has to give you in the question the number of trials. So he will say for you, toss a coin 10 times. So when I say toss the coin 10 times, this means the number of trials is 10. The success also should be given in the question. Okay, when I say what is the probability of obtaining 3 heads, so this is the success, heads. So he will give you the success in the question and the n trials. He doesn't have to say that the experiment follows a binomial distribution or there are 2 possible outcomes. This should be, you should understand this by yourself. Well, the third condition, as we mentioned, the trials are independent of each other. So if one outcome is a success, this doesn't influence, this doesn't influence the chance of another outcome being a success. Okay, so if you toss a coin once, you get a head, you don't say, okay, now the second time I will be, of course, get it a head again. No, every time 50-50, okay? There is no influence. So in this case, we say the trials are independent of each other. Also, he will not give you this information in the question. You must know it or find it by yourself. The process must be consistent in generating successes and failures. That's the probability P associated with a success remains constant from trial to trial. So each time you toss a coin, the probability of obtaining a head is 0.5. It doesn't change. This is another condition. The probability of success remains the same from trial to trial. The probability of success has to be given in the question. So in any question about binomial distribution, three things must be given: the number of trials, the probability of success, and the success itself. What is the success? Which outcome is the success? So what is P, the probability of success? So in tossing a coin, he will just say, toss a fair coin 10 times. When he say toss a fair coin, it means probability of head is equal to probability of tail. Both is 0.5. So this is given in the question. You know it, you should know it, okay? But in other examples, he has to give me P. So he will say, for example, we know from past experience or from past records that 40% of students at PSU are not Saudis. 40%. This is the probability of success. And maybe success would be not Saudis in this case. Or maybe he will change it when he asks the question. He did not ask anything. He just gives an information that 40% of students at PSU are not Saudis. Now listen to the continuation. Select 20 students of PSU. What is it, 20? Now 20 is in the number of trials. What is the probability that 5 of them are not Saudis? So not Saudis is the success. If he says, what is the probability that 12 of them are Saudis, then Saudi would be the success. Okay, so he's going to choose. And what is the experiment in this case? Each student, we will find his identity, whether he is Saudi or not. So 2 outcomes, Saudi or not. And we will do this for 20 students. That's it. That's the binomial experiment, and we will do it 20 times. P is given, which is 0.4. N is given, which is 20. And he can ask his question. What is the probability of obtaining 5 of 20 would be non-Saudi, or 12 of 20 would be Saudi? We will be able to answer this question in a while. Now, P is probability of success. Q is the probability of failure. If P is the probability of success, Q would be the probability of failure. We only have 2 outcomes. So if probability of success is P, what would be Q? It would be 1 minus P. So if 40% of students at PSU are not Saudis, then what is the percentage of Saudi? 100 minus 40%, 60% would be Saudi students. So 1 minus P. So P is probability of success, Q is the probability of failure. Now, this is the binomial formula. This is how can we find probability of X. We have to memorize and understand this formula. Now he asked, what is the probability that 5 of 20 are non-Saudis? So he was asking about probability of 5. X was 5, the number of non-Saudi. Now, we need to understand, yes, here, we need to understand the values of X. X runs from where to where. X is the random variable, okay? When I toss a coin 10 times and I ask about what is the probability of obtaining 3 heads, so I'm talking about number of heads. So X, the definition of X is number of successes. Number of successes. From how many trials, or in how many trials? In how many trials? In N trials. So X, the number of successes in N trials. So what would be the values of X? X would be, how many successes out of N? You could get 0 success, 1 success, 2 success, up to N success. You cannot get more than N success because you have only N trials. You cannot get negative success. You cannot get 1.2 success. Okay, so X runs from 0 to N. This is very important. So in this question, I selected 20 students, so X is from 0 to 20. And now I'm asking about probability of 5. How can I find probability of 5? Well, this is the formula. N factorial over X factorial times N minus X factorial. What is the meaning of N factorial? This is the meaning of N factorial. N factorial means N times N minus 1 times N minus 2 up to 1. So for example, how to find 7 factorial? 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can evaluate this by the calculator. There is a button here. You can, above X inverse, you can say 7, and then press Shift X inverse, you get factorial. This 7 factorial, 5040. It will give you immediately the answer. This symbol, okay? So 5040. So this is what we mean by factorial. So N factorial over X factorial times N minus X factorial, this is denoted by NCX. So what is NCX? This is, we call it combination. So NCX, it is, what is NCX? The number of choosing X objects from N objects. The number of selecting X objects from N objects. Number of combinations of X objects selected from N objects. So for example, I have 30 students in the class. In how many ways can I select 5 students? Okay. In how many ways can I select 5 students out from 30 students? The answer would be, the number of ways would be 30C5. Okay. We write it like this, or in the calculator, we write it like this, or you may see it like this also. It is written like this, okay? All of these are used, okay? All of these symbols are symbols for combination. So when you see this symbol, it means N factorial over X factorial over times N minus X factorial. What does it mean? N factorial, 30 factorial. Okay, the larger the number in trials, okay, over X factorial, which is the second number or the number below, 5 factorial, times the difference between them, 30 minus 5, which is 25 factorial. Okay, so you can find it by the calculator immediately, because you have here in the calculator also above the division, okay, NCR. So you write 30 first, you say 30, and then you press Shift, and then you press division, and then you write 5. The answer would be a huge number, 1,402,506. Okay, this would be the number of possibilities that we can choose 5 students out of 30 without any arrangement. There is no arrangement in combinations. So here we have NCX. So N here is 20, X is 5. So I have 25 times P, the probability of success. We said that 0.4, 40% are not Saudis. So 60% are Saudis. So P, Q, P times Q. And then you raise P to the power 5, which is X. So P is raised to the power X to the power 5, and 0.6 is raised to the difference, N minus X, or 20 minus 5, which is 15. And you can ask the calculator to evaluate this probability, and you can find the answers. So this is the binomial formula. We always use it to find probability of x, probability of 5, probability of 0, probability of 1, to any value of x from 0 to n. So P is the probability of success. Q, or 1 minus P, is the probability of failure. Remember, 0 factorial is 1. This is by definition. If you ask the calculator to evaluate 0 factorial, you will get 1. All right. So let us solve a question, exercise. For a binomial distribution with a sample size equal to 10. So n is 10. This is the sample size. And probability of success equals to 0.3. So P is 0.3. What is the probability that the sample will contain exactly 3 successes? So X is 3, and he asking about probability of 3. So N is given in the question, must be. P is given in the question. So any question about the binomial distribution, you will have a number, which is N, and a decimal, which is the probability. Okay, so X is 3, or find probability of 3 successes. Well, let us use the formula. Probability of 3 would be N is 20, so 10 C3. I will always use this symbol, 10C3 times P, which is 0.3. And what is Q in this case? If P is 0.3, Q would be 1 minus 0.3, which is 0.7. You raise P to the power 3, and you raise 0.7 to the difference, 10 minus 3, which is 7, and you use your calculator and find the answer. Let us find it once. So 10 shift C3, okay, 10C3, then you say times, then you write 0.3 to the power 3, then you say times, then you write 0.7 to the power 7, and then you ask for the answer. The answer as a probability would be always a number between 0 and 1. So it's 0.27. This is the probability of 3. You can find, of course, what is, that's the end of the question. We answered the question. But what is X here? X runs from where to where? From 0 to 10. And if you want to construct the probability distribution of this experiment, so you can make a table, all values of X from 0 to 10, and this is the probability of each X, and you can, for example, probability of 3, we found that it's 0.27. You can use the binomial formula to find the probability of each of these values, and the sum of all probabilities at the end should be 1. So this is called the probability distribution of this experiment. Here he did not ask about it. He only asked about the probability of the sample will contain exactly 3 successes. Let us take another example. Use the binomial formula to calculate the following probabilities for an experiment in which n is 5, p is 0.4. N and p are given. What is the probability that X is at most 1? What is the meaning of at most? At most 1 means it cannot exceed 1. So X is less than or equal to 1. So he's asking about probability that X is less than or equal to 1. Now, what are the possible values of X? You need always to understand the possible values of X. The possible values of X are from 0 to n. What is n in this case? 5. So 0, 1, up to 5. So when he says X is less than or equal to 1, means X equals what? What are the possibilities? It could be 1 or what or 0. These are the only 2 numbers less than or equal to 1. So in fact, he is asking about probability of 0 and probability of 1. Well, probability of 1 is using the formula, okay? N, what is n? In this case, n is 5, X is 1, times P, what is P? 0.4, times Q, what is Q? 0.6. plus also 5, but this time 0, times p, which is 0.4, times q, which is 0.6. Here you raise 0.4 to the power 1. Here you raise 0.6 to the power 5 minus 1. Here 0.4 is raised to the power 0. Here 0.6 is raised to the power 5 minus 0, which is 5. And you can find the answer, and this will give you probability of x less than or equal to 1. There is something called, of course, if I ask you, for example, to find probability of x less than or equal to 3, then you will have to find probability of 0, plus 1, plus 2, plus 3. You may use the distribution many times. We will solve this problem mainly we will use the calculator. I will teach you, inshallah, in the next time how to use the calculator to get probability of x less than or equal to. But there are tables. You can use them if you like, but in the exams, we will not give you the tables. You have the calculator, you can use it, and I'll teach you how to use the calculator. But if you have the tables, or if you want to use or to learn about tables, this is the cumulative binomial distribution. And cumulative, as you remember, means less than or equal. Cumulative means less than or equal. So in this table, you will see the probability of x less than or equal a number, okay, which is summation from 0 to x. This formula, the binomial formula. There is a table for each n. If you remember in this question, in our question, n was 5. So n2, n3, you go to the table of 5. This is n4, where this is n5. Okay, this is n5. So n is 5. The p, where is p now? You search for p. P was 0.4 in our question, so this is 0.4. Okay. Now we needed probability of x less than or equal to 1. If it is less than or equal, you will find it in this table, because this table gives you probability of x less than or equal. But if it is greater than or equal to, then you have to do something. You cannot find it, you can find it from this table, but not directly. You have to use less than or equal always. So probability of x less than or equal to 1, this is 1. Where is the answer? The answer would be 0.337. So this table gives you the answer quickly. So the answer here should be 0.337. Please check it at home. Add these two probabilities and check that the answer is 0.337. I will stop here. And that's all about binomial distribution, but we will solve many exercises next lecture.